will be recorded. Currently, we have you on mute. To unmute yourself for questions at the end. If you're not familiar with Teams, you can see the bar in the center of your page right next to the camera icon. You can click on the microphone icon to unmute yourself. We'll leave the bulk of questions until the end where we have time for discussion built into the training. But certainly if you have questions during Dave's presentation, you can see the little comment box next to the, or raise your hand right there on the right-hand side of the toolbar as well. So if you would like EEN credit for today's training, please type your name and the company in the chat feature, and we'll make sure to connect that with our EEN team coordinators to ensure that you get credit for today. And I think at this point, I will introduce Dave. So Dave is a native Vermonter. He's a former air sealing and insulation contractor, a nationally known speaker. He's a recipient of the Wigington Leadership Award and a proud grandfather. He's been trying to make homes work better for 36 years and somehow isn't done yet. For those that don't know, the Linda Wigington Leadership Award celebrates visionary leaders doing extraordinary work to strengthen the home performance and weatherization industry. This award showcases individual excellence in leadership as demonstrated by outstanding initiative, impact of work, and inspiration to others. So we are very lucky to have Dave leading the training today. I also want to mention that this is the first of a series of trainings on the residential building energy standards. And we have another series for the commercial building energy standards coming up. I will provide links to those in the chat so that you can visit our website and plan accordingly. We will also have this recording posted, as well as some other recordings posted for self-paced learning as well. So with that, I'm going to hand it over to Dave.
Okay, thanks, Bryn. I'm turning off my camera because I'm working from home like most people, and like a lot of Vermonters, my signal is sketchy. So let's see if I can share my screen here. And if all went well, you folks should be looking at title slide, all blue, Vermont Residential Building Energy Standards.
There you can see it.
Okay, so we're off and running. So this is divided up into several sections. We're going to go through these one at a time. As Bryn said, we're going to save the bulk of the questions for the end. Feel free to send them in on the chat function or raise your hand. I will be checking in a couple times during the session to just make sure that we don't have anything pressing that should be addressed right away. So the first section is an overview where we talk mostly about the organization of the code, a little bit of the history where it came from, not very much. And administrative stuff, how it's organized. Then we go to the basic requirements, which is a list of 10 or 12 things that basically have to be in place in all houses. The next section is the ventilation and combustion safety section. This is a short piece on mechanically ventilating the house and making sure the smoke always goes up the chimney. And then we'll do a short section on existing homes as opposed to new construction. And then we'll get into the 3 ways that a builder can demonstrate that the house meets the overall performance requirement of the code. There's 3 options there. One is packages plus points. We'll talk about how that one works. The second option for the builders is a software program where they describe the features of the house and find out if they pass or not. And the third option for the builder is a home energy rating, which is a third-party numerical certification. And then at the end, we'll talk about the certification, that is the paperwork that the builder needs to fill out. So the overview. The code basically requires that builders, first of all, it's the builder who is on the hook. What the code says is that the builder should figure out what the code says, build the house in accordance with the code, and certify that he or she has done that. So part of that is the basic requirements, like I said, those 10 or 12 things, ventilation and combustion safety. And then the builder picks one of 3 methods to determine whether they meet the overall performance requirement. So we'll go through all of those. And then at the end, there's paperwork, not too much of it. So before we jump into what the 2020 code is going to say, this piece here may not be that useful for those of you who are not already familiar with the code, but probably several of you are. So I'm just going to very quickly summarize the changes for 2020. These will kick in this fall on the 1st of September. So one is that we have new insulation requirements, new packages. We've always had packages in the code. Every time we revise the code, the bar gets raised a bit, so it gets bumped up, R value requirements and such. And the package approach in the past was simply pick a package and do everything in the package. With this round, we have packages plus points, which means that you pick a package if you choose to go this route. You pick a package and then you choose from a list of optional points to accumulate additional points. And the reason you accumulate additional points is to accommodate house size. This will be the first time in the Vermont Energy Code that the size of the house makes a difference in terms of what the requirements are. And basically the code is set up now so that if somebody chooses to build a quite large single family residence, they're pushed to make it a little more efficient than somebody who is who's building a small, modest house. There are more options for ventilation. We've had a requirement in the code for mechanical ventilation since 2005, but with this round, there are more options. None of the old options have disappeared, but the builders have more flexibility now. Blower door testing, that is air tightness testing of the building, is now required. In the current version of the code, the one that's in effect as I speak today in June of 2020, blower door testing is not required. There are air sealing requirements, and blower door testing is optional and a way to meet those requirements. With the 2020 code, blower door testing will be required for all new construction. You might want to know on the side that the same is true of the commercial code. All new construction commercial in Vermont will have to be blower door tested after the 1st of September also. Electric resistance heat is mostly prohibited in the state of Vermont in terms of residences. There are a couple of exceptions. There are requirements for electric vehicle charging infrastructure for some projects, basically multifamily and Act 250. The infrastructure is pretty minimal. Basically, the idea here is that at the time of construction, when it's cheap to put in the cabling and to rough in the boxes, that the code says that for some projects, you're supposed to do that at the time of construction, just to make it easier to install electric vehicle charging later on. And there are some requirements for solar ready for the stretch code. This is a similar thing where you're not actually required to put solar on the house, but if you have to comply with the stretch code, there are requirements that you put the cabling in place so that if somebody wants to add solar later, it's easier and less expensive. So that's the changes for 2020. Back to a brief look at the history. We've had an energy code in Vermont since 1998. Kicked in 98 for Act 250 projects and 99 for everybody else. This is based on the International Energy Conservation Code, which is the most common national energy code in the United States. It's intended for residences. This is a performance-based standard, which means that overall, what the code says is there's a certain level of performance that you're supposed to get to, and you should have lots of options for getting there. That's the idea between performance-based. The code clearly has specific items that are required, but overall, in a broad general sense, the main requirement is that the house just meets some minimum level of performance, and the builder has lots of options for getting there. What we did in Vermont, we adopted the International Energy Conservation Code, and we bumped up the requirements a little bit. And we added a few Vermont-specific stuff, and I'll try to identify those as we go through them. In Vermont, there's no system of code officials or inspectors attached to the residential energy code. This is a self-certification thing. Basically, it says that the builder is supposed to figure out how to comply with the code and sign a certificate saying that they did that. There is a 3-year revision cycle. As a practical matter, it tends to get stretched out into somewhere between 3 and 5 years, but every 3 to 5 years, the code gets revised. This is a public review process, and I would encourage anyone that thinks that the code should be otherwise than it is to get involved in that process. So every time we go through the cycle, there are public documents posted on the Public Service Department website. There are public meetings, and there's plenty of chance to either attend a meeting or comment via email, that sort of thing. Our new code kicks in on September 1st, 2020, and applies to all projects that start construction on or after September 1st. Starting construction is generally considered to be what some folks in the trade would call breaking ground. So it's the beginning of the on-site work. There is a separate code beyond the basic energy code, which we call the base code. This separate code is called the stretch code. It is very much like the base code, but it's a little more stringent. In this case, a little stronger preference for continuous insulation on walls, for balanced ventilation as opposed to exhaust-only ventilation. The bar gets raised a little bit. This is required for Act 250 projects. That's been the case since 1998. And it also can be adopted by municipalities who want their energy code to be more strict than the state's base code. So municipalities can do this. Personally, I'm only aware of one in Vermont that has done this. That's South Burlington. But I know other towns have talked about it. I wouldn't be surprised if other towns have done it as well. Which buildings must comply? This is a residential code. It only applies to residential buildings and residential parts of buildings. It applies to 1 and 2 family dwellings, which in the code world is the same thing. It also applies to multifamily housing, 3 stories or less. That 3-story delineation is very common in the code, in building codes. Very often, once you get above 3 stories, you're dealing with different types of construction, different rules. And in Vermont's case, once you get above 3 stories, you have to comply with the commercial code, whether it is residential construction or not. Otherwise, it does not include commercial buildings. That is, it doesn't include offices and storefronts and such. But it does include a residential portion of a mixed-use building. So if there's a 3-story building with storefront on the first floor and apartments above, the commercial space on the first floor has to comply with the commercial code. The residential space has to comply with the residential code. It also applies to existing low-rise residential building. Low-rise means 3 stories or less. If you're building an addition, the addition has to conform to the energy code, and the rules for additions are exactly the same as they are for new construction. So you're basically building it as if you were building a new house. You do not have to do anything to the existing portion of the house. You just need to build the addition in compliance. There are times when you may be doing work on an existing building when the energy code may kick in. So if, for instance, you're replacing windows, the windows that you put in are supposed to comply with the energy code. If you are insulating certain parts of the building, you are expected to comply with the energy code if it's feasible and reasonable and space permitting. And we'll get into that in a little more detail when we get to the existing homes piece. The stretch code is required for all Act 250 projects. I think we said that already. Log homes are a special thing in Vermont. This is not the case with the national code, but when the legislature created our Vermont code, they carved out a special place for log homes. And the log homes in Vermont are allowed to be less efficient than all other forms of construction. I'm not aware of any other construction style that is singled out in this way. There are more stringent requirements for some parts of the building to make up for what could be characterized as the insulation deficiency of the walls, because there's no way a log home is ever going to meet the wall R value requirement. So they got cut a little slack on that one. There are exemptions to the code. There's an exemption for extremely low energy use buildings. So if you're building a house where the peak energy load in the house is less than 1 watt per square foot, then you are exempt from the energy code. For those of you who are not familiar with that unit of measure, watts per square foot, if you have a 2,000 square foot house, then what this means is that on the coldest morning of the year, you should be able to heat it with 1 watt per square foot, which for a 2,000 square foot house would be 2,000 watts. And for those of you who don't have a feel for what 2,000 watts is, it's a little more than a hairdryer. Most common size of a hairdryer is 1,750 watts. The small ones are down around 1,500. The big ones are around 2,000. So it's basically a big hairdryer. Mobile homes are exempt. Mobile homes are regulated at the national level, and states are not allowed to put additional restrictions or requirements on mobile homes so that they can cross state lines freely. So the mobile homes are what they are. I should be clear here that we're not necessarily talking about modular or manufactured homes. Mobile homes are defined very specifically by that act that you see there on the slide, and they have to have certain characteristics in order to be called a mobile home. And the single most distinguishing feature is that they have a permanent chassis beneath them. In other words, they're always on wheels. Those items are exempt from our energy code. Now, site-built components are not exempt. So if, for instance, you choose to pour a foundation and put the trailer on the foundation, then the foundation should comply with the energy code. Or if you put an addition onto the mobile home, the addition should comply. Buildings or parts of buildings that are not heated or cooled are exempt. In this case, by heated or cooled, what we mean is heated or cooled by either fossil fuels or electricity. The code does not consider a bio-based machine to be a heating source unless it involves electricity. So your wood stove is not a heating source. So what this means as a practical matter is if you have a residential building and the only heat is a wood stove and there is no air conditioning, then that building is exempt because the code considers it to be unconditioned space. Now, that's for a wood stove. The same does not hold true for a pellet stove, because a pellet stove does use electricity and is considered a heating system. So if you have a pellet stove, the building does need to comply. Hunting camps, which I mentioned in the beginning, hunting camps are exempt from the code. The vast majority of them would be exempt anyway because they have no heating system. And most of them have no electricity. So they would be exempt for those reasons anyway, but for whatever reason, in '97, when the legislature created the energy code, they felt it appropriate to carve out a special spot for hunting camps. There's also a special treatment of historic buildings. They are not automatically exempt from the code, but they can apply for an exemption. So if you're working on a building that's formally designated as historic and you think the energy code is interfering with something you want to do with that building, you can apply for an exemption to be allowed to go ahead. There's also a special carve out for what's called owner builder projects. This is Vermont specific as well. This does not exist in the national code. And the idea here is that the intent is that someone who is building a house by themselves for themselves to live in is allowed to build it any way they want. Now, they are not outside the scope of the energy code altogether. They still have requirements under the code, but they're not required to meet the technical requirements of the code. That is, they can build the building any way they want. So they are specifically exempt, not from the overall code, but from meeting the technical requirements of the code, you know, the R value of the walls or the efficiency of the windows, that sort of thing. There's a very specific definition for an owner-builder, and you're not allowed to call your project an owner-builder project unless you meet this definition. So the owner has to be the individual who is directing the details of the construction, must live in the building, must own the building. The key thing here is directing the details of the construction. So the intent here is that this owner who is going to be living in the building is on site running the project. If there is some sort of general contractor who's making the day-to-day decisions and dealing with the subs, then that individual is the builder, not the owner. In order for the owner to call themselves an owner builder, they have to be running the project, and they have to not have a general contractor for that project. They still have to figure out what the code would require of that building, and they have to document how their building does not meet those requirements. So the documentation is quite similar, actually. The timing of the paperwork is different. For most of the code, for standard treatment code, the certificate is supposed to be filled out at the time of completion. For owner-builder projects, they don't need to do that until they get ready to sell. But they do have a legal requirement to disclose in writing to potential buyers before the purchase and sale agreement how the house does not meet the code. This does not prevent the sale from going through. The sale can still go through even though the house does not meet the technical requirements of the code. So there's no hard impediment to sale, but we like to remind folks that if they choose to build this way, then the building may be perceived to be less value at the time of sale, because if it doesn't meet the code, presumably it's going to have higher energy bills. And so a buyer might get skittish at an owner-builder project where they would not get skittish if they had the standard certificate that said everything was up to par. So there is some liability in the code, although we hear frequent criticisms that there's no enforcement, which is kind of true. There's no system of fines or penalties. There are no inspectors. The real teeth in the code is that the homeowner can sue the builder if the building does not meet the code. They can sue for increased energy costs. That probably is a small number, but they could also sue for the cost to bring the building into compliance. Presumably there's legal and court fees involved in that, as well as most builders don't like to see their name in the newspaper under the day in court. There is a limitation to that. The claims must be filed within 6 years. So a couple of things about real estate transactions. I've already said this, but the lack of the code certificate does not cloud the title. So the sale can still go through, but it may raise questions of value on the part of either the buyer or the lender. And I just mentioned this in the context of the owner-builder certificate, where you're actually certifying that the house, isn't up to snuff in terms of the energy code. But it also applies when the code certificate simply does not exist, and this is pretty common. We do get phone calls from folks who are trying to get a sale through, and the bank has sent somebody to the town clerk's office to do a title search, and they have noted that there is no energy code certificate. So although the sale can still go through, it does not cloud the title. It definitely can snag things, and there are some lenders in Vermont who won't issue the mortgage unless the certificate is on file. So one more reason to pay attention to this, try to make sure the documentation is up to snuff. I've talked to some very disappointed homeowners who were trying to sell their house. The certificate was not in place. The buyer's bank is balking now. And in some cases, the original builder has left town or has died or gone out of business or is unresponsive. And that can be a problem for the seller. Okay, so that's kind of the overall organization. We're going to take another quick reminder about what the code requires, the basic requirements, the ventilation and combustion safety. The builder needs to pick one of these three methods to assess whether or not the building meets the overall performance requirement. And when they're done, they need to do the certification. So in the next piece, I'm going to talk about how high the bar is, just to give everybody a sense of what's required by the code in terms of the level of stringence. So we're going to be talking about R values for walls, R values for ceilings, that sort of thing. So two things on this piece. I'm going to skip through this fairly quickly. I'm just trying to give you an idea of how strict the code is. How high is the bar? In general, if you do this level of stuff on all the pieces in the building, you will meet code. But here's the important part, is that the code requires overall performance. Remember, the builder picks one of those three methods to demonstrate that the overall performance is there. So when I give you, for instance, in the next couple of slides, the R value for walls, that's the R value that the code is aiming for, but that doesn't mean you have to build every house you build that way. You are allowed to do some things in some parts of the building that are less efficient than this, but you have to make up for that somewhere else in the building. That's the idea. So the next few slides, the next 6 or 8 slides, I'm going to show you how high the bar is, but don't panic. It doesn't necessarily mean you have to do every single one of these things in every single house. The window requirement is maximum 0.30 U factor. Most of you are probably familiar with R values, the way we rate insulation, and some of you are familiar with U values, but some of you may not be. U values is the unit of measure that we use for windows and doors. It also describes how efficient it is in terms of slowing down the transfer of heat. R values and U values are reciprocals and they work in opposite directions. So with R values, higher numbers mean better performance, and you'll generally see a minimum R value of something. For U values, lower numbers mean better performance. So often it's expressed as a maximum. So the maximum window U value is 0.3, and the maximum U value for skylights is 0.55. That 0.30 is a good quality window with double pane, argon fill, and low E coating, or perhaps a triple pane. And with log homes, the amount of glazing on the house is limited so that you're only allowed, your walls can only be 20% glass, essentially. 20% glass is a lot of glass. For ceilings, the minimum R value is R49, so that's essentially what we're aiming for. The code does have other language in it. You're allowed lower levels of insulation in the attic if you can get your full height all the way out over the outside walls. Some of you probably realize this is often not possible because of the clearance between the top of the exterior wall and the underside of the roof sheathing at the two eave edges. So the R49 applies if that's the case, but if you can get at least R38 over everything, you only need to do R38. Slope ceilings have the same requirement actually, although if you only have a small quantity of slopes in the house, you are allowed R30 rather than R38. For wood framed walls, the minimum is R25. R13 cavity insulation plus R10 continuous is deemed to be equivalent. Obviously 13 and 10 do not add up to 25. but the R25 allows cavity insulation only at R25. And R10 continuous works significantly better than R10 cavity. So R10 cavity plus R10 continuous probably actually works better than R25 cavity only. For mass walls, which is concrete walls above grade, so this is not basement walls, it's also not log walls. This is concrete above grade. The minimum is R15, assuming that at least half of the insulation is on the outside of the concrete. If more than half of it is on the inside, then you need at least R20. That's assumed to be continuous insulation. For floors, minimum R30, that's floors over outside space. For basement walls, this is the same as the current energy code, R15 continuous or R20 cavity insulation. It's assumed to be full height from the top of the wall to 10 feet below grade or to the basement floor. And there is a requirement in the code that if you're doing insulation on the outside, you have to have a protective coating to protect the foam from the sun, and also from little boys with baseball bats and bicycles. If you have an unvented crawl space, what the code says is you treat that essentially just like a basement. The wall insulation requirement is the same, and they specifically call out for a good vapor barrier on the floor, everything taped, and no vents if you're doing an unvented crawl space. If you're doing a vented crawl space, then it's all outdoors, you vent it freely, and you insulate the floor above, and that floor is now subject to the R value requirements. For slab edge, this applies to basically slab on grade. The code talks about slabs that are at grade, above grade, or within 1 foot of grade. So this does not apply to the slab in a deep basement, for instance. So if you have a slab that's at or near grade, it's an R15 perimeter insulation, or R10 perimeter plus R7.5 under the rest of the slab. And the assumption there is that you're using foam insulation and that this is a 4-foot configuration, that is either a piece of rigid foam which is 4 feet high, in which case it probably goes from the slab to the frost wall. But what's also allowed as an alternative to that is that some portion of the foam run vertically and then some portion of the foam run horizontally, and that those two dimensions add up to 4 feet. For a heated slab, a radiant slab, you're required R15 edge and under the whole thing. And again, if you're exposing exterior insulation, it has to have a protective covering. So at this point, we've kind of covered the overview, the administration, and also some idea of the stringencies. I'm going to pause right here and check with Bryn. Do we have any compelling, immediate questions that need to be addressed?
Hi, Dave. We do not have any clarifying questions or anything immediately asked right now, so I think you're good to continue. Okay,
so on to the basic requirements. So as I said, this is a list of 10 or 12 things that have to be present in all houses. And I'm going to show you the list right now. Air sealing, vapor retarder. We're going to go through all of these one at a time. Ductwork, pipe insulation, basically a lot of mechanical stuff here. So to begin with, air sealing. The code has long required that builders make a reasonable effort to make the building airtight and seal up any leakage locations between conditioned space and outside, and conditioned space and unconditioned spaces like an unheated garage. New with this round, as I mentioned earlier, blower door tests are required. So the house does have to pass an air tightness test. The individual conducting that test has to be certified to do so. There are 3 acceptable certifications. One is the certification from the Residential Energy Services Network. This is a national certification associated with home energy ratings. The second certification is from the Building Performance Institute. This is another national certification, and this is a certification associated with the retrofit industry. So for instance, most of the home performance contractors in Vermont have staff that, well, all of them have staff that carries BPI certification and knows how to do blower door test. And then the third acceptable certification is one issued by the state of Vermont, for which individuals take a half-day class and pass a multiple choice test. The tightness level that needs to be reached is less than 3 air changes per hour at 50 pascals. So this is 50 pascals is just the industry standard to which we test. 3 air changes per hour relates the leakage of the building to the volume of the building. So this is a way to accommodate for different size buildings. And the way the code accommodates for different size buildings is by using that unit of measure, air changes per hour. You might want to know that the industry as a whole is moving away from using air changes per hour to compare different buildings of different sizes, and is instead moving to a system where we will compare those buildings not according to their volume, but instead according to their surface area. So that's a better way of doing it. The industry is going to go there. But right now, what we're using is air changes per hour. You'll see on the last line there that the stretch code also requires reporting in cubic feet per minute at 50 pascals per square foot. So this is the surface area measurement that I've been using. You'll notice that they don't have to pass any specific number there, but they're required to report what that number is. And probably everyone should be thinking in terms of the energy code will probably move to that unit of measure and away from air changes per hour. I'm guessing probably with the next code revision, but if not that, almost certainly the one after that. Quick look at what air sealing is talking about. We're talking about a continuous layer around the building that is durable, stops the air. All the breaks or joints sealed. Space between windows and rough openings. Plumbing and wiring penetrations. Junctions of the foundation sill plate and rim, et cetera, where different pieces of the building come together. There's a specific call out for the rim joist, where you need to either use air impermeable insulation, which probably means foam, or if you use a permeable insulation, which means something like fiberglass or cellulose or rock wool, you have to put a rigid interior air barrier on that assembly. You need to do the same thing at the edge of any floor insulation. One way you could think of this, if you're having trouble picturing it, is to picture a raised ranch, which is a 2-story house where on one side of the house, typically on the street side, the second floor overhangs the first floor by about 2 feet. So you've got a 2-foot section of that top floor that has outside air under it. Commonly, folks traditionally would have put fiberglass bats in there. And if you were to look at that assembly from the inside before the finished ceiling goes up, or if there isn't a finished ceiling, you'd be looking at the raw edge of that fiberglass bat. And what the code says is that's not acceptable. You can't let inside air get out there and circulate around on those cold surfaces. And you need some kind of durable air barrier at that edge of the floor insulation as well. Other utility shafts, ducts, flues, etc. Any air leaks between the garage and conditioned spaces, this should be given really, really high priority because this is not just an energy issue, it's also an indoor air quality, health and safety issue. Tubs and showers, behind electrical boxes, communication boxes, speaker boxes, common walls between units in multifamily, HVAC register boots, and then just a note here that log homes have their own standard for air sealing. Well, that's interesting. My graphics are in the wrong order there, but no big deal, I guess. The code does require a vapor barrier on some walls. That is, this is the interior side of frame walls. So that's it. It does not require vapor retarder on ceilings. It does not require it on below grade walls. Only on the interior side of frame walls, above grade frame walls. Class 1 or Class 2 vapor retarders are required in those cases. A Class 3 vapor barrier is allowed if you have one of those 3 assemblies that's given there. And the reason for that is that those assemblies are thought to be more resistant to moisture and condensation problems at the exterior side of the wall. They keep the condensing surface warmer or allow the moisture to escape more easily, and so they're a little more forgiving. They don't need as vigorous a vapor retarder. There are some things for heating and cooling in the basic requirements. If you're putting in heat pumps, they have to be cold climate heat pumps, and they have to have no electric resistance heat in them except for frost control. Electric resistance heat in general is prohibited unless you're replacing already existing electric resistance heat. It is allowed in some areas like bathrooms and stairways where it's cost prohibitive. Where your primary heat is a heat pump, you can do electric resistance as a backup, but only if it has controls that prevent it from operating when the outside temperature is above 5 degrees, and the house is tested to have an air tightness less than 2 ACH 50. You'll recall that the requirement for houses in general is 3 ACH 50. 3 ACH 50, by the way, is pretty easy to get to if you're paying attention and trying. And 2 ACH 50 is, I would also characterize that as not terribly difficult if you're paying attention and trying. But if you're not paying attention and not trying, you're unlikely to get there. And electric resistance heat is also allowed in multifamily buildings with heating loads below 6 BTU per hour per square feet. So in other words, very, very efficient buildings that don't need much heat. And in that case, only multifamily. And this is just a side note that electric resistance heat is not allowed in Burlington without the approval of the Burlington Electric Department. This is not in the Vermont code, but as long as we're talking about electric resistance heat in Vermont, probably worth noting. There are requirements on sizing. The code says that before the heating and cooling equipment is purchased, somebody is supposed to figure out how big it should be. To some people, this seems like, why is there even a requirement here? Like, doesn't everybody always do that? But the answer is no. It doesn't always happen, and in some places it usually does not happen. So what the code says is that you are supposed to figure out how much heat the building needs, and you're supposed to put in a unit that corresponds to that heating load. Manual J is the industry standard for this. It's been used in the heating industry for decades. Any competent heating contractor should be familiar with Manual J and should be able to present the Manual J calculations, whether they do it themselves or they have their suppliers do it. You can do it on paper, you can do it on the computer. Lots of options, but the code says it's supposed to be done. And then the code says you're supposed to put in equipment that's informed by that information. So if you're putting in air conditioners and heat pumps, you shouldn't be putting in a machine that's any more than 15% bigger than what Manual J told you you needed. If you're doing combustion devices, that is fossil fuel devices where you're burning something, you're not allowed to put in any equipment that's more than 40% bigger than is required according to the heat load calculations. Anecdotally, it's not at all uncommon. In fact, it is very common in Vermont to find brand new houses with boilers that are literally twice as big as they need to be. And it's not all that unusual to find boilers that are 3 times as big as they need to be. So often this has an efficiency impact. For some things like air conditioners, it also has a performance impact. They actually work worse when they're bigger than they're supposed to be. And of course, it has an economic impact on the front end, because the bigger the systems are, the more they cost the homeowner. There are also requirements over controls. You're required to have a programmable thermostat unless you have a radiant heat and you have a 5-wire connection. In other words, you got good wiring in place, so to provide lots of flexibility for how that's controlled in the future. If you have an internet connected thermostat with a 5-wire connection, you do not need to be programmable. Although I'd note that I'm not sure that an internet connected thermostat which is not programmable even exists. And if you are doing a cold climate heat pump, they typically come with their own dedicated thermostats, and often they are not designed for setbacks, and setbacks are less useful and sometimes detrimental with heat pumps anyway. So that lots of times the standard recommendation with heat pumps is set it and forget it. Don't do setbacks. And boilers and air-to-water heat pumps must have an outdoor reset control. Outdoor reset simply means there's a thermometer outside, and there's a control that varies the temperature of the distribution loop according to how cold it is outside. So if it's not very cold, they're circulating water that's not very hot. And as it gets colder and colder outside, they circulate water that's hotter and hotter. Also, requirements on ducts. If you run your ducts through the attic or through any other unconditioned space, they have to be wrapped with a minimum R8, and they have to be buried in ceiling insulation of at least R40. This is a lot of insulation. And note that unless you're smart about where you put them, and you put them right down low on the ceiling to begin with, it's really hard to bury them in ceiling insulation of at least R40. That's a foot on top of the ducts. And in addition, all ducts must be air sealed, whether they're inside the house or outside the house. The idea is that they should, some attempt should be made to make them airtight. You can't use building cavities as ducts or plenums. You need balancing dampers or some sort of adjustable register so that the system can be balanced on a room-to-room basis. And if the air handler, also known as the furnace, or any ductwork is located outside the conditioned space, ducts must be tested for air tightness. So this is a pretty vigorous requirement. Note that it only kicks in if you run your ducts outside the insulation layer. And the real intent here in the code, I believe, is not to punish people for running them outside as much as to discourage people from doing that in the first place. And this is entirely appropriate because running your heating and cooling ducts outside of the thermal envelope is just plain stupid, and comes with a fairly high performance penalty. So the code recognizes this, and so what it says is if you choose to run through the attic or some other unconditioned space, first of all, you have to really very, very heavily insulate all the ductwork. And you have to have the ductwork tested. This is a test similar to a blower door test. Uses equipment that's the same in concept, a little different in the terms of the size of the fan and the way that it hooks up, but it's the same type of test. And then you have to pass that test. Presumably you have to pay for somebody to conduct that test. So there's the code makes you jump through a couple of pretty big hoops if you choose to send any ductwork outside. So please don't send any ductwork outside. Pipe insulation is required for any mechanical system piping designed to carry fluids above 105 degrees Fahrenheit. So that applies to the hot water distribution on your boiler, and it also applies to domestic hot water pipes, or at least the hot water side. There are also requirements for pools, hot tubs, and spas. If you heat your pool, the heater has to have an on-off switch. You can't have a pool heater that runs the pilot continuously. Heated pools and hot tubs must have an insulated vapor retardant cover, at least R12, unless you're getting most of the energy for that pool from solar or from some other non-depletable site-recovered energy source. I think that unless you have a windmill, this probably means either solar or cordwood. At least 90% of the bulbs in the building needs to be high efficacy. That means, as a practical sense, it means something better than an incandescent. So CFLs still meet that requirement. And the modern smaller diameter linear fluorescents also meet it. The old style larger fluorescent tubes that were 1.5 inches in diameter, the T12s, they do not meet this requirement, but the smaller T8s and T5s do. And then, as I mentioned, the last basic requirement is for vehicle charging stations. So if you're doing the base code and you're doing a development of 10 or more units, a minimum of 4% of the parking spaces must have a socket capable of providing either a level 1 or a level 2 connection within 5 feet of the center line. I would note that this is not a terribly strenuous requirement. Level 1 charger is regular household current, like the outlets in your house. So this is just a standard outlet within 5 feet of the center line. And for most developments in Vermont, you're probably going to have 10 or fewer units, and you're probably only going to have one level 1 charging station required. Doesn't mean you shouldn't do more than that, but that's the requirement. It's not required if you're using storage or if it's used to store vehicles who are being serviced, or if you are separated from the meter by a public right-of-way like a street, or spaces that are restricted to durations of less than an hour. And also, the total number of EV spaces need not exceed the number of EVs driven by occupants of the building. Although occupants of the building, that's subject to change, right? So you might not want to commit to that for the long haul. For the stretch code, for single family, you need one level 1 charger. So basically, that's a standard household current outlet, within reach of where you're going to park the car. For developments of 10 or more units, it's the same as the base code, but any level 1 service locations must be level 2 ready. So that means that back at the panel box and the cabling must be sufficient to carry 240 volts. And you need signage indicating where those EV-ready things are. So that's the end of the basic requirements, and we're going to go on to this piece about ventilation and combustion safety. The code has required since 2005 that you must have mechanical ventilation in the house. That is, you must have some system of 1 or more fans on some kind of control capable of providing some minimum flow according to how big the house is. Up until now, we've had, up until 2015, we only had one option for that, and that was the Vermont prescriptive method. And I'm going to explain to you what that one is. That's the simplest one. Starting in 2015, we were allowed to use ASHRAE 62 instead. And with the new code, the 2020 code that kicks in September, 2 more options have been added. So you can now choose from these 4 standards. We're not going to go through the first 3. I am going to show you the 4th one. So the first one, ASHRAE 62, is the national residential ventilation standard. This is from ASHRAE, obviously, It's very well known, it's very well accepted, and in most places, if there is a mechanical ventilation standard for new homes, this is what it probably is. There are a couple other ones. There is one from Building Science Corporation. Some of you might be familiar with Building Science Corporation. They're an architectural engineering firm in Massachusetts, headed up by a fairly well-known gadfly named Joe Stiebrick. And Building Science Corp, being who they are, they didn't like any of the standards, so they made their own. And that is an acceptable standard according to the Vermont Energy Code. Also, you could use, if you choose the Passive House standard, this comes from the Passive House certification system, which if you're not familiar with that, that's a certification system out of Germany, which is, I think it's fair to say, a very aggressive standard that requires very high levels of insulation, very tight buildings. And as I said, they have their own ventilation standard. You can choose to comply with that one. Or you can choose the Vermont prescriptive method, which I'm going to show you in the next couple slides. Your whole home system can be, it says the whole home system and be, but there's missing a C there. Sorry about that, my bad. Whole home system can be exhaust only or balanced. The fans must be rated for continuous duty. There are some efficiency requirements based on the type and size of the fan. In other words, they have to be able to move a certain amount of air using a certain amount of electricity. Equipment within 4 feet of grills, so this would be something like your typical bathroom exhaust fan, must be less than 1.5 zones, so it's got to be reasonably quiet. And just a note there that if you buy a fan that has the Energy Star label, it meets those requirements. Local ventilation is required in bathrooms that contain either a tub, a shower, or a spa. They have to be a minimum 50 CFM intermittent or 20 CFM if they run continuously. And those local ventilation fans do not have to meet the sound requirements or the efficiency requirements above. They can basically be anything if they're not part of the whole house system. The code says you have to have some controls that are capable of running the system regardless of what the humans do. So you can't have any system that requires people remembering to turn things on or off. You can do automatic, you can do continuous. For automatic, we're basically talking about timers. So some kind of control that turns things on, turns things off according to some prescribed program schedule. You can, if you choose, run your ventilation system continuously rather than automatically. Continuous means just exactly like it sounds. It runs all the time. If that's your scheme, you're not allowed to have an on-off switch locally. That is in the bathroom right there where it would be easy for someone to shut it off. You do have to have an on-off switch, but it has to be remote and it has to be labeled. So if you're going to go this route, this probably is a separate switch, perhaps next to the electrical panel, that just can be a very simple on-off switch, but it has to be labeled as a ventilation system. There are some requirements for installation. Ducting must be air sealed, and you have to air seal it without using duct tape. For those of you who don't know, duct tape was never intended for sealing ducts. The name is an error, and it is particularly poor material for sealing ducts. You shouldn't use duct tape on ducts. You need smooth walled ducts for runs over 8 feet. You're not allowed to use corrugated stuff for longer runs. Ducts in unheated spaces, like through an attic, have to be insulated. You have to use mechanical fasteners to attach ducts to the fan. Most tapes are not durable enough for this. Remotely mounted fans must be acoustically isolated from framing and from the ducts. You'll notice that the fans that are mounted within 4 feet of grills, as I've already said, they have to meet a sound requirement. They have to be below 1.5 zones. If you mount the fan remotely, it does not have to meet any particular sound requirement, but they do require that you mount it in such a way to minimize the amount of vibration and noise that's transferred to the framing. Any outdoor intakes you have has to be at least 10 feet from contaminants, so probably the driveway is not a good thing, and at least 1 foot above the expected snow level. Screens, louvers, or grills on intakes and exhaust. So this is the required flow rate if you're using the Vermont system. So if you're using ASHRAE, the Building Science Corp, or the Passive House standard, it does allow you more flexibility, and you might be able to get by with smaller fans, but it's more complicated. So your choice. If you want to use the prescriptive standard that we've had in Vermont for the last 15 years, this is what it says, and that's the CFM capacity that you have to provide based on the number of bedrooms that you have in the house. Pretty simple. There are some other details about heat recovery ventilators and energy recovery ventilators. So these are balanced systems that move, they use 2 fans instead of 1. They move air out of the building, they move air into the building, and they provide for some amount of heat recovery between those 2 air streams. So if you're trying to comply with the base code, an HRV or an ERV is not required if you're using packages plus points. So in other words, you can use exhaust only there. If you're using the software or the home energy rating, you are required to do either an HRV or an ERV. And if you're doing stretch code, you have to do balanced ventilation. And if you're doing balanced ventilation, or more accurately, if balanced ventilation is required, you must have ECM fans, and for an HRV, a heat recovery ventilator, you have to have minimum 70% sensible heat recovery. And for an ERV, an energy recovery ventilator, you have to have a minimum 65% sensible recovery efficiency. A couple other things on ventilation. If you have a huge kitchen exhaust, you got to have makeup air. Over 400 CFM is a lot of exhaust. This does not apply to your standard exhaust hood in your standard house. But there are some, especially upper end houses that have, almost commercial restaurant style cooking equipment. And sometimes they will have rather large vent hoods that move an awful lot of air. And what the code says is if your exhaust moves over 400, then you have to have a dampered, automatically controlled makeup air unit. All clothes dryers have to be ducted to the outdoors. There is an exception for condensing clothes dryers. You may know that you can buy a condensing clothes dryer now that is not designed to exhaust at all, and condenses the water out of the clothes and sends it down a house drain rather than pushing it out through the outside air. That's it on the ventilation stuff. Now we're on to the combustion safety stuff. This is not a huge deal, but it does take a minute to explain because it's not something that a lot of people have dealt with specifically. So the code does deal with combustion safety in a couple ways. One is it prohibits unvented fuel-fired heaters. That prohibition has been in place since, well, I guess I'm not sure about it. Certainly since at least 2015, but I think it actually was before that. So although you probably still can find unvented fuel-fired heaters in Vermont, you're not allowed to install them in houses. The most common form of these is what's called a vent-free fireplace. So a manufactured unit looks like a fireplace, burns gas, and is specifically designed to dump 100% of the combustion gases into the living space 100% of the time. Those are not allowed in Vermont, in residences. Generally speaking, the combustion safety requirements are pretty much focused on making sure the chimneys work. And the idea here is that in tight buildings, and we want our buildings to be tight, you can set up essentially a tug of war between the exhaust fans and the chimney, because the chimney is trying to pull air out of the house and exhaust fans are trying to do the same thing. And if the house is fairly tight, there may not be enough air to keep everybody happy. So when we get into a tug of war between the chimney and the clothes dryer, we want the chimney to win, because if the clothes dryer wins, then all the smoke goes into the house. So that's the idea. And one of the requirements is all chimney vented combustion equipment must establish draft within 2 minutes under worst case conditions. This is a specific performance test, and the way it's done is that the building is sealed up as tight as it can be, and all the exhaust fans in the building are turned on. So that's the kitchen exhaust, the bathroom exhaust, the clothes dryer, central vac, if there is one and it's vented to the outside. And then under those conditions, the combustion appliance that's hooked to the chimney is fired up, and it has to overcome the suction developed by those exhaust devices. So that's a specific performance test, and basically says that when all of the exhaust fans gang up and try to suck air down the chimney, the assembly has to be such that they can't do that. And another requirement is that there has to be combustion air for any gas or oil appliances vented into chimneys. There is a little confusion about this because in most of Vermont, the gas and oil codes have not been formally adopted. So chances are where you live, there's no oil code. And chances are where you live, if you're not on Vermont Gas's system, there's no enforced gas code either. And those are the codes that we look to for details on how to provide combustion air. So it's a little confusing, but the Vermont code requires that combustion air be provided. It requires that it be provided as specified in the national gas and oil codes, even if those codes have not been adopted in the local area. Also, those codes use a phrase called unusually tight construction, and they say, that is NFPA 54 and 31, the National Gas and Oil Codes, they say that things change when you are dealing with unusually tight construction. The Vermont Code specifically makes clear that any house that meets the Vermont Code is unusually tight construction as defined in the gas and oil codes. So it's not really unusual at all, it's usual. And the ramification of this is that the national gas and oil codes allow equipment to be installed without combustion air if they are installed in a big enough space. So that's what that means, the volume of the space. So what they essentially say is, if you put a gas boiler in the basement, you don't need to put in combustion air unless the building is unusually tight construction. So what we're saying with the Vermont Code is we're always unusually tight construction, so it's always required. Don't bother even talking about volume. You got to provide the combustion air. Also, taking combustion and dilution air from attics and crawl spaces is specifically prohibited according to the Vermont Energy Code, even though those things are allowed in the national gas and oil codes. So you have to provide combustion air all the time, regardless of the volume of the space, and you have to provide it all the way from outdoors, not from a crawl space or an attic. We also have requirements for solid fuel. Solid fuel devices, essentially wood stoves, must have gasketed doors with compression closure or compression latch system, unless the house has passed the worst case depressurization test. So it does allow you to get around that if that fireplace or that wood stove or that pellet stove has passed the worst case depressurization test. Solid fuel combustion air must be delivered directly to the firebox whenever possible. So if you're putting in a new wood stove, it should have a combustion air duct from the outside to the firebox. The easiest way to do this for most stoves is to buy the manufacturer's approved kit, and most of them have approved kits. They're usually sold as optional, but they will have one most of the time. If you're building something on site, like a site-built fireplace, you also have to provide combustion air, and you have to follow the installation requirements that are in the code. So even though I haven't put those details in here, in the code itself, it has detailed installation requirements for site-built air inlets, including how big they need to be, where they need to be located, what kind of materials do they need to be built out of, that sort of thing. Okay, on to existing homes. Before we go there, Bryn, do we have any clarification questions that should be addressed immediately? Oh, I can barely hear you.
Sorry about that. We don't have any questions in the chat, but is there anyone that wants to take a moment now to ask Dave a question or two from what's come up? You can either enter that in the chat or you can unmute yourself by clicking the microphone button. Okay, not seeing any questions. Looks like you're okay to keep rolling along.
Okay. On to existing homes. So one thing to understand about the code is it doesn't say you have to change your house. What it does say is if you're making changes in your house, some of those changes may involve energy code requirements. So for instance, if you're insulating, this is re-insulating an existing home. The intent is that you go to the code if you have room, but you're not required to build the assemblies thicker in order to have room. If you're replacing windows, the windows have to comply. Combustion safety requirements apply when you make the building substantially more airtight. The code does apply to additions, alterations, renovations, or repairs to an existing building system, or portion thereof. And again, that phrase right there, that sentence is directly out of the code, word for word. And again, unaltered portions need not comply. So just because you're insulating your attic doesn't mean you have to do something with windows or basement or whatever. It does apply to a change of unconditioned to conditioned space. So if you're finishing off an area that has previously been unconditioned, so this could be an unconditioned basement, it could be a garage that you're turning into living space, maybe it's the room above the garage that you're turning into living space. If you're doing that and creating new conditioned space, the requirements are the same as for new construction. So even though you're not building the walls or building the roof, those walls and roofs have to comply with the same R value requirements as new construction, because even though there was a structure there, there was not conditioned space there. So you are creating new conditioned space. So it's the same as new construction. I guess I said that. Maintenance and repair is exempt. So, you know, fixing things, repairing things, changing out simple components is exempt. And obviously anything that has no effect on energy use in the building is exempt. So if you're painting the building, it's exempt. If you're building a deck, it's exempt. You're putting a new roof on, it's almost exempt. It's probably exempt. So general maintenance stuff is exempt. If you're building a garage, that's exempt as long as it's not heated, that sort of thing. Walls are exempt unless the cavities are exposed. And if the cavities are exposed, they must be filled with insulation. So this would apply to something like a gut rehab, where you're taking off the interior finish of the walls. You're looking at bare studs, empty cavities. Those cavities have to be full when you're done. you're probably not going to get to that R25 requirement for walls, but you don't have to, because this is an existing wall bordering existing conditioned space, and the requirement is only that you fill it up. You don't have to be building it thicker. Almost everybody in Vermont would do that anyway. Re-roofing is exempt unless you expose the sheathing or the insulation and the cavity is completely empty. So the difference between walls here is that with walls, they just have to be full when you're done. That's all. With roofs, you don't have to do anything unless they are completely empty when you start. And in that case, they have to be full when you're done. Replacement of less than 50% of the light fixtures is exempt. Also, replacement of bulbs and ballast in existing fixtures is exempt. So if you're not replacing the fixture itself, you have no particular requirements there. You might recall that the standard requirement for new construction lighting is that 90% of them be high efficacy. You only need to meet that requirement if you're replacing more than 50% of the light fixtures in your scope of work. So, for example, let's say you're doing a kitchen renovation and the kitchen has 7 lights in it. Well, if you're replacing 5 of those lights, then you need to have a high efficacy lights for at least 90% of those 5 lights. And of course, you can't do, if you did 4 out of 5, that'd only be 80%, right? So they all have to be. So in that kitchen where you've got 7 fixtures, if you're replacing 5 of them, they all have to be high efficacy. But if you're only replacing, let's say, 2 or 3 out of the 5 light fixtures, you have no particular requirement at all. You should do LED anyway, but you're not compelled to do so. And storm windows and glass replacement is exempt. So it's only the full-blown window replacement where the code kicks in. So that's the existing one. On to the next section, which is packages plus points. So just to review, this is one of the 3 ways that the builder can demonstrate overall performance. So everything we've done up to this point is all things that everybody has to do. The basic requirements, the ventilation stuff, the combustion safety stuff. Everybody does all of that. And then one of 3 ways to demonstrate overall performance, you're either going to use packages, you're going to use the ResCheck software, or you're going to get a home energy rating. So this section is about the packages. There are 5 packages for the base code, 3 for the stretch code. You're going to pick one of those packages. We're going to take a look at them in just a minute. And then you're going to choose options for your required additional points. How many additional points do you need? It depends on how big the house is. So you look at the total conditioned floor space of the house. That is any space that is conditioned, even if it's not finished. So this will generally include the typical Vermont basement. It would also include any storage or utility spaces that are within the thermal envelope of the building. So perhaps a mudroom if it is inside the thermal envelope. So if you're building multifamily units less than 2,000 square feet each, you need 4 additional points. If you're building single family less than 2,000, you need 5 points. 2 to 4, you need 7 points. And over 4, you need 10 points. So as I mentioned in the beginning, this is the first time in the Vermont Energy Code where it makes a difference, where the requirements that you have to comply to vary according to how big the building is. This is something that not everybody agrees on, but a lot of people have wanted to see in the code for a long time. And we're going to take a look now at the base code packages. So the way this is set up is each vertical column is a package, and each horizontal line is a piece of the building. So we'll take a look at this. We're going to start with package 1, which is standard. Package 1 is essentially the code R values. So you'll see these are essentially the same ones that I showed you early in the presentation when I went through and said, you know, this is how high the bar is set. That's essentially this package. And if you're in an existing home and you're only changing one piece of the building, or maybe you're changing a couple pieces, but not the entire one, and you're wondering, well, what R value do I need to go to for this piece of the building? You need to go to the R value that is listed in package 1. Those are the standard requirements. R25 wall, R49 ceiling. You'll notice that some of these carry little footnotes with them. And I'm not going to show you the footnotes here, but when you get into the handbook where it explains this in more detail, all the footnotes are there. So you have to comply with those. Sometimes it's just a clarification of what the details require. So you've got your ceiling R value, wood frame walls, common walls if you're doing multifamily. There's your exposed floor R value. This is your basement or crawl space wall, R15 continuous or R20 cavity. There's the slab edge stuff. It's the same numbers I mentioned early on, and also with that 4-foot idea that the insulation is either 4 feet high or it's a combination of vertical and horizontal that adds up to 4 feet. Then you have the heated slab stuff, which is if you have a radiant slab, there's your windows, your skylights, your air tightness, which is the same for everybody, and your duct leakage, which in these packages, package 2 and package 4, it all is all inside the thermal boundary. In package 3, you are allowed to have some duct leakage to outdoors, but of course you're going to have to test for that. And then percent high efficacy lamps. So this package 1 is the standard package. It is the package for existing homes. And it's pretty easy to build to for contractors that are used to pretty standard construction. And especially if they are willing to put on some continuous insulation on the walls, which they don't have to, but it makes compliance a little easier here. Package 2, you'll see is labeled as SIPs, which stands for Structural Insulated Panel. And this is intended for buildings with SIPs panels. In Vermont, most of these buildings are post and beam frame. And that's why they have a continuous insulation R value for both ceilings and wood framed walls. And these R values are what is commonly available in SIPs panels. There are often other areas in the building that where some other things may have to be changed because some package doesn't measure up to package 1 standard in some way. In this package, everything else is the same as package 1, even though these R values look lower at first, but note that these are all continuous R values. And these are achieved with foam, which is not going to have air blowing through it, et cetera, et cetera. So the performance is actually pretty similar. Package 3 is described as a thick wall. You might want to choose this if you're building a double stud wall. And you can see that the wood framed walls is a thick, well, in this case, they're not talking about a double stud wall. They're talking about a conventional stud wall, which has thick continuous insulation. The rest of the requirements, I think, are the same, except for this testing requirement for ducts. And then package 4, which is labeled as cavity only. This is essentially designed for builders who do not want to do continuous insulation on the walls and would like to continue building 2x6 walls with cavity insulation only. This package allows you to do that. So there you have it, R20 cavity insulation for wood framed walls. Now, that R20 is less than the performance level that the code would like to see us at, so you have to make up for that somewhere else in the building. And in this case, you're making up for it by doing more attic insulation. So you've got a higher attic insulation requirement. You also have a higher window requirement, 0.28 max rather than 0.30 max. So you're required in this package to have better attic insulation and better windows, and that makes up for the fact that your wall cavity is only R20. And then package 5 is only for if you're building a log structure, and you can see what it says there. It refers to that ICC standard, which is also incorporated into the code in a table that's given right here. So those are the packages. The idea here is in order to use this method, you're going to pick one of these packages. And if you're using the package, you have to do each individual piece at just as good as it's explained there. So you're not allowed to, be a little bit less on one and be a little more on the other. You have to do each individual line at least as good as it says. And then once you've selected your package, then you choose how to get your points. And I'm just going to skip back to the previous slide just for a second to remind us that let's just stick with single family here. If we're doing less than 2,000 square feet, we only need 5 points. 2 to 4 is 7 points, and over 4,000 is 10 points. So that's how many points you need. We'll skip past this and on to the points. This is what the points look like. This is about 2/3 of them. I'll show you the rest on the next slide. You can choose where you want to do your points, and whether you want to do it in the thermal envelope by doing better thermal envelope, maybe better insulation in the walls, maybe a better insulated ceiling, maybe better windows. Or maybe you want to choose to do it in air leakage and ventilation. You can get a point if you do a second blower door test before things are done to give you a chance to fix stuff if there's defects. You can get points if you build the house tighter than required, and you can get even more points if you build it really tight. Maybe you choose to get your points with heating and cooling. So you upgrade the heating and cooling system to something a little better. You can get points for that. And you can do that whether you're doing furnaces, boilers, you're doing heat pumps, any of that. And then there are a few more options for points. You could do it with water systems. You could do a low flow system. You could do certified water efficient design according to one of these standards. You could do a drain water heat recovery. You could do a controlled hot water recirc system with user demand by a push button for furthest fixtures. This is a cool idea. It's basically a recirc loop. So there's a central loop of hot water that travels as close as possible to all the final use fixtures. And then only the short little stubs are used off of the main loop. The idea here is that you get hot water when you turn the tap on very quickly, and you waste very little water that you have already paid to heat. So the guy who is the kind of prime driver on this kind of system nationwide, his elevator pitch is, I can devise a system in any house where if you turn on the hot water at any fixture in the house, regardless of whether it's been used recently or not, you will never wait more than 5 seconds for hot water, and you will never send more than a cup of water down the drain. And that's a hard standard to meet, but he meets it. You can do it with renewables, with solar ready, or with solar installed. You can do it with solar hot water. Or you can do EV ready. You can do a demand response battery like the Tesla Powerwall. You can do a whole house monitoring system. So there's lots of options here for how to gather your points. You could pick, anything you want there, as long as you add up to however many points you need, which again depends on how big the house is. If you're building a modest size house, you probably only need 4 points. And there's probably something on this list that, you know, is easy to do, or you're going to do it anyway. We'll cover the stretch code. It works the same way. So different packages and you need more points, but the process is still the same. So there's the points you need. It's basically 2 or 3 more points than you would need on the base code. These are the packages. There are only 3. We went through the other ones in detail. I'm not going to spend quite as much time on these, except to say that, you know, again, package 1 is our standard package. Package 2 is a SIPS package. It's intended for structural insulated panels. And package 3 is the thick wall system, so it's intended for thick, continuous insulation. So you're going to pick one of those packages. Note that for the stretch code, you're required to have balanced ventilation all the time. And the stretch code points, very similar. They're not quite identical to the other ones, but very similar, you know, so you can do better insulation, you can do more airtight, you can do better heating and cooling equipment. You can do more efficient water system, you can do renewables or batteries, EV monitoring, that sort of thing. So that's how the packages work. You pick a package that you can live with, and then you pick enough points to get you to the level that you need, and you are deemed to comply with the overall performance. So that's one way. Another way you can comply with the overall performance is to demonstrate that using the ResCheck software. You're only allowed to use this method if you have balanced ventilation and if you have 2 ACH 50 or less. This still involves a lot of houses. There are an awful lot of houses being built these days in Vermont that do have balanced ventilation. You also see that even where it's not required, that is one way you could get your extra points if you wanted to upgrade to that. And air tightness of 2 ACH 50 or less is not a terribly stringent requirement. So for those of you who are not used to that unit of measure and don't really have a feel for what 2 is, I'll just point out that the code maximum in general for all houses in Vermont is 3 ACH 50. The code maximum for houses in a lot of other states where the climate is not as severe is 5 ACH 50. 5 ACH 50 is really easy to get to. At the other end of the spectrum, if you look at fairly tight requirements, you may recall that I mentioned the passive house standard in the context of ventilation, because we're allowed to use the passive house mechanical ventilation standard. Well, passive house also has a requirement for air tightness. And in order for a house to be labeled as passive house, it has to have an ACH 50 of less than 0.6. That's a very aggressive number. So just to give you an idea of how the numbers run, passive house is 0.6, which is a very aggressive standard. 2 ACH 50 that we're looking at here, I wouldn't consider that a terribly oppressive standard, but you know, it does require some effort. The 3 ACH 50 that's required of all houses in Vermont, I would characterize as pretty easy to meet if you try. The software method also can't be used for stretch code, so you have to be base code, balanced ventilation, fairly tight. The software is free. You go to the Public Service Department website, and in fact, that website that's given right there, that page, is where all the code stuff lives. So you want to take note of that. I think we also have it on the last slide of this presentation. But that's where all the code reference materials live. So that's where you can get this. the software, but that's where you can get a copy of the code handbook when it comes out. You can get copies of materials from previous codes. So if you need to go back for whatever reason, you can get that information. You can get copies of the certificate, that sort of stuff. So all of that lives at that one website page at the Public Service Department. And what you're going to do is describe all the parts of the thermal envelope by entering the square footage and then the R values. R values for walls and ceilings and such, U values for windows and doors. So that's the way it looks. That's the way it operates. The software does all the calculations, gives you all the answers, tells you pretty much instantly whether you pass or not. And all you need for this is you need all your square footages and all of the R values and U values. The software screen looks like this. The first time you open up the software, you have to tell it what code you are trying to comply with. And you may see up at the top, you've got the menu up here, and one of the menu items is code. If you click that, you'll get a drop-down menu. One of the options will be the Vermont Residential Energy Code, so you're going to choose that one. Once you've done that once, it will default to the Vermont code unless you change that. So once you use the software for the first time, you pick a code, you close the software down after you're done with it, you open it up a week later, and it will default to that code that you have previously selected. That's why it says at the top up here, it says Vermont Residential Building Energy Standards. There are 3 pages, but all the action basically happens on this one. So you'll see where my cursor is here, there is a project page that's pretty much just boilerplate information, name, address, condition, floor, area, that kind of stuff. And there's a mechanicals page, but there's really nothing to do there. So you can pretty much ignore that for a variety of reasons that I won't go into right now. We're not allowed to put much of any mechanical requirements into the code. We can reward people for doing something better, but we can't establish a floor that's any higher than what the federal government has established. Basically, it's just a matter of there are national standards because the equipment gets shipped all over the place, and there's a desire to not have individual states having different standards for stuff, like we do with cars. So the action happens on the envelope page. You'll see these buttons up here that correspond to different pieces of the building. So what you're going to do is you're going to fill in all the stuff in the bottom and describe the building. So the way you start is you just hit one of these buttons, and that will create a line. So this is just a screenshot. It's not live, but if I were to hit this ceiling button, it would create this line right here, which is called Ceiling 1. And you're going to get a drop-down menu here where you'll have choices about what type of ceiling it is. This is a flat ceiling. The full text here says flat ceiling or scissors truss. So you'll choose from a drop-down there, and you'll put the area of that ceiling here, and then you will put the insulation R value in one or both of these 2 columns. You'll notice there's cavity insulation, there's continuous insulation, and these 2 mean exactly like they sound. Cavity insulation is insulation that is separated by framing. Continuous insulation is insulation that has no breaks in it. And in this case, this was filled out by somebody else a long time ago, but it has R49 for cavity insulation and no continuous insulation. You can put entries in one column or both, whatever is appropriate to what you're describing. You'll notice that in this house, there are 2 ceilings. We can't combine the 2 ceilings together because they are insulated differently from each other. So you can create as many ceiling lines or walls or floors or whatever you want. And you need a separate line for each item that is different than the others. If they're insulated exactly the same, you can lump them all together on the same line and just total the square footages together. So really all you're entering here is you create the line, you choose from the drop-down menu, you put in the square footage, you put in the R value. In the case of windows and doors, you'll be putting in U values rather than R values. So we create the ceilings, then we create the walls. You should probably do these in the right order. So that's the order across here. If you create a ceiling and then you create a skylight, the software will assume that that skylight is in that ceiling. And that's the way it'll appear here. You see how where door, window, and this second door is bumped in from wall? So the software thinks this door, this window, and this door are in this wall, whereas this door is in this wall. So the way you do all of that is you just create them in the right order. So you create the ceiling, and then if there's any skylights in that ceiling, you hit skylight next. You create wall, and you describe the wall, and then if you next hit window, it will assume the windows are in that wall. If you hit door, it'll assume the doors are in that wall. And it will subtract out the square footage. So when you put the square footage of the wall in, you want to put in the gross square footage, including the windows and doors. And then when you do the windows and doors and delineate their square footage, the software will subtract that out from the wall square footage. So just remember, when you're describing the wall area, it's the gross area, including the windows and doors. And you'll notice that in this house, there are two separate wall areas. There's this wall. We'll see, looks like the vast majority of the wall is this one, wood frame 16 on center, R13 cavity, and R6 continuous. And this other wall, smaller amount of area, it looks like it's built the same way, same cavity insulation, but thicker continuous insulation. So it's insulated differently. It has to be called out separately. And then same thing with the floors, drop-down menu, square footage, R value. If you had an exposed slab edge or basement wall, you would do that. This is your slab on grade here. So this is probably I'm not sure what this is, but it's slab on grade for a portion of the house. Looks like it's over unconditioned space for this floor. I'm not sure exactly what that assembly is. But anyway, you describe all of the pieces of the thermal envelope. There's more room here than it looks. You can make a lot of lines if that's what it takes. And all the time you're doing this, the software is continuously doing the math, and it's displaying the result down below. So the way this software works is it creates a building according to the description that you're giving right here. And then simultaneously, it creates this second theoretical building. And the theoretical building is the same size and shape and location as yours, but it has exactly the code values of insulation, no more, no less. It's code compliant, just barely. It's right at the code compliant line. And so what the software does is it compares the heat loss of your building to the heat loss of this theoretical reference building. And if your building has a lower heat loss than the reference building, then you pass. And if you have more heat loss, you fail. Simple as that. So this one passes, and if it passes, you see in the lower left down here a green check mark and the word passes. And over here on the right, you see a number in green, and that is your percentage better than code. And you notice that this building just barely passes, 0.3%. So the heat loss of this building is 99.7% as much as the heat loss of the reference building, the theoretical reference building. So it passes, but just barely. If it doesn't pass on your, if it didn't pass, first of all, this would be in red. It would be an X rather than a check. It would say fails. And over here, it would give you a percentage, but it would say worse than code. If that's where you end up, you're going to have to change something in order to pass. So you just ask yourself, what can I change? And whatever thing you think you might be willing and able to change on the real building, you just change that on the software. So maybe the easiest thing for you to do is to buy windows with a lower U value. If that's what you're thinking of doing, then just hop into where the window U value is and change it to whatever number you would put there instead. Whoops, sorry about that. Inadvertent advance. And the software will immediately, like in less than a second, it will tell you what the results of that change are. So you can, it's very easy to play what if. You can play what if to your heart's content. What if I just took this square footage of wall here where I only have the R6 continuous and I just put R10 continuous like I did on all the other walls? How much difference would that make? So that's all of the, all of your options are there. And I'll just mention one more thing about this before we move on, and that is this column called UA. For those of you who are not familiar with that unit of measure, UA is simply the U value, which is the heat loss, times the area. So U is just the heat loss per square foot, and the area is just the square footage. So UA is the total heat loss. This is a very useful column to look at if you want to just ask the fundamental question, where does most of the heat in this building go? And where are the areas where I might, because if you're going to change things, you might want to go to the places where the heat is leaving. And you can see from these numbers that the two places where we're losing the most heat are, whoops, sorry. I'm used to clicking on this stuff, the circle around it, are this wall where the UA is 71, that's the biggest heat loss in the whole building, and the slab on grade perimeter, which is a 64. But again, the windows are a fair bit of it. So, the windows account for 57 out of the total. So it's just good to go here and look and see, where am I going to make a difference? Am I going to make a difference by treating this ceiling right here? Well, probably not, because it's only accounts for 8 to begin with, where I got all these other components that amount to 50 or 70 or whatever, 40. So the UA can kind of just gives you a good feel of where the heat is going. And if you want to stop it, you got to go to where it's leaving. Okay, on to the next slide. So the things to remember for the software method are use for ceilings and walls, use the gross area, and then the windows and doors will be subtracted out automatically. Use the rated value of the insulation alone. This is a pretty common question. For instance, somebody will say, well, what if I build a 2x4 wall and I put in fiberglass bats that are rated R11? What's the R value of that wall? And that's a very reasonable question, because the only number given there is 11, and that wall is not R11. That wall has bats in it that are R11. Just to finish out that thought, some parts of the wall perform better than R11. That is where the insulation is, because you're getting R11 out of the insulation. You're getting some additional R value out of the interior and exterior sheathings, out of the siding, etc. It may not be a lot, but it's something. And then there are also parts of the wall where the R value is less than 11. And those are the parts where the insulation isn't, in other words, the framing. So if you wanted to figure out the actual heat loss of that wall, you would take the parts of the building where the insulation is, the cavities, and you would add to the R11 the insulating value of the other layers. And then you would go to where the insulation isn't, the framing, and you'd figure out what the insulation level is at that, where you just basically got solid wood all the way through the wall. And that would be a number a lot lower than 11. And then you'd have to apportion that. You'd have to figure out, well, what percentage of the wall is at this R value? What percentage of the wall is at the other R value? Do all the calculations, and you would eventually come to the effective R value of that wall. And for the wall we're describing, R11, the effective R value most of the time is closer to R8. But the way the code works, the code does not require the builders to jump through all those hoops. The intent of the software here is that this is a do-it-yourself thing by somebody who knows buildings, but is not necessarily an expert in all of these heat loss calculations. So for simplicity's sake, what the code does is it says, don't worry about the extra layers. Don't worry about the deficiencies of the framing. Just use the rated value of the insulation alone. So only the materials that are labeled as insulation and only the rated value of that material. So that wall, we would describe it in the software as R11 because it has R11 insulation. The same is true of the packages, by the way. I didn't mention this when we were going through the packages, but also for the packages, wherever they say an R value, they're talking about the rated value of the insulation alone, not the overall assembly R value. If you have different R values within the same component type, you enter them separately. So, you know, if you've got different wall sections, you're insulating differently, you just create a separate line for each. Make sure that you include all the basement windows and doors if the basement walls are part of the thermal envelope, which they probably are. If you have access hatches and their R value is different than the surrounding area, you just enter those separately. So you might have one line on your software that is a ceiling, and it's only 5 or 6 square feet because it's your attic hatch. And you just enter the R value, whatever you insulate your attic hatch to. So that's it for the software method. And now we're on to the home energy rating, which is the third way that a builder can demonstrate overall performance compliance. A home energy rating is not done by the builder, it's done by somebody else. So the first two methods were intended to be do-it-yourself stuff for builders. This last one is not. This last one, you're going to have somebody else do this. Home energy ratings are done according to national standards, and across the country, in most states, there's some sort of home energy rating system involved. In most states, the builder would pay for the rating on the open market. That's not the way it works in Vermont, although theoretically you could do that in Vermont. But in Vermont, most of the home energy ratings that happen under the umbrella of Efficiency Vermont. They're done by Efficiency Vermont staff, and they're done for projects that are in Efficiency Vermont's new construction program. So just to be clear, Efficiency Vermont does not do home energy ratings for a fee. It also does not do home energy ratings for projects that are not involved in the program. But if you're involved in the program and trying to meet those program requirements, you get a home energy rating as part of that process. And incidentally, the home energy rating includes a blower door test, so you're going to get a blower door test as part of that process too. Under the first two schemes, you are required to have the house blower door tested, and the presumption is that you're probably going to pay for that. The way the home energy rating works, the house ends up with a numerical score, and that reflects its efficiency. So the way the scale is set, net zero is 0. So a score of 0 means that the house needs no purchased off-site energy. So they're not buying any oil, they're not buying any gas, and they're not buying any grid electricity. Whatever energy they're using, they're manufacturing on site. That's net zero, and that house would get a score of 0. At the other end of the scale, they've pegged a score of 100 at a barely compliant with the energy code house. And this is not the Vermont energy code. This is a national energy code, so it's a little different. But the way to think about it is if you considered a national average energy code, a house that built according to that standard would have a score of about 100. A house that was worse than that would have a score of more than 100. Better than that standard would be less than 100. And it scales with the energy use. So 0 means 0 energy use. 100 is pegged to a specific amount of energy use. If the house only uses half of the energy of the house that scores 100, then that house scores 50. If you want to get started on the home energy rating, the way to get started is to contact Efficiency Vermont. And in fact, this chapter on home energy rating, this section, is the shortest section in this presentation because this is the only slide. You don't have to know how to do this. The Efficiency Vermont staff knows how to do it, and they'll step you through. But again, it's only an option if you are involved in Efficiency Vermont's new construction program. And with that, we are on to the last section in this presentation. Thanks for hanging in there. I know that it's hard to sit alone in a quiet room where you don't even have another human being to look at, and you're watching a presentation which has no pictures in it. So thanks for hanging in. We're close to the end. The certificate, which you obviously cannot read in this picture, provides a couple of things. It provides details about the house, a fair number of them, and it provides the builder's word that the house meets the code. We are going to take a closer look at this certificate just briefly. And what the contractor is supposed to do is to fill it out, make some copies, post one copy at the house, file one copy in the town land records, and mail one copy to the Public Service Department in Montpelier. So that's the obligation of the builder. This is the top half of the certificate, and I don't want to spend a whole lot of time on that, but I just want to give you a general sense of what this involves. You may or may not be able to read this. If you're looking at a large monitor, you probably can read it. If you're sitting somewhere watching this on your smartphone, then you might as well just listen. At the top is just boilerplate stuff: construction start and finish. What kind of project is it? What's the street address? Is it an Act 250 project? That sort of thing. And then down here in this next section, we've got the compliance method. If you want to use the package plus points method, you would check option 1 there. If you're using the ResCheck software method, you would check option 2 there. For the HERS rating, you check option 3. If you're using the packages, it also will ask you which package are you using. So you'll delineate that here. How many points were you required based on the size of the house, and how many points have you achieved? And then down here, you check off how you got those points. So basically, this looks very complicated, but actually it's just you check that you did packages plus points. This is the package I used. This is how many points I was required, and this is how many I achieved. And I achieved those points by doing the things that are checked. So you just check off the things that you did. If you're using the software, there is a checkbox here just to remind you that you are required to have an HRV or an ERV in order to use this method, and that your tested ACH 50 must be under 2. And so it just asks you to check that off. What is your ACH 50? And what is the UA? And you'll require you may recall on the ResCheck software, there is I didn't specifically point it out, but right at the bottom there is a total UA number, and so that's the number that you would put in on this blank. If you choose the HERS rating, you would choose this, and you would put in the numbers from the HERS rating. And actually, this would probably be filled out in advance by the person who did the rating, and they would put their name in right there. Down here where it says thermal envelope, you just fill in the R values that you did in the building. Down here where it says air sealing blower door test, you just report the results of your blower door test. Here where it's the ventilation system, you simply check off which type of ventilation system you have, balanced or exhaust only. If it has a sensible recovery efficiency, you would fill that in that blank right there. And you check off whether it's a rated flow or a measured flow. And then that's the top half of the certificate. Bottom half of the certificate, there's a combustion safety section, and that's just check boxes. Yes, I did this. Yes, I did that. For the mechanical system, the design load calculation method, how did you do it? Did you use manual J, which is the most common one, or did you use some other approved method? And if you did, you're supposed to put down what method you used in here. And then all of these numbers are numbers that come out of the heat load. So if you're the builder and you're needing to fill out the heat load calculation, if you're going to need to fill out the energy code certificate, this certificate, you're going to need these numbers, and they come out of the heat load calc. And so you should ask your heating system guy for them. And guy is non-gender there, by the way. It's a habit I have, sorry. I should be more specific. If your heating system person tells you that they haven't done a manual J, you should inform that person that it's required by law, and it's their requirement to do it, and it's their requirement to give you those numbers. And then you also fill in your primary heating system size and your primary cooling system size. So you're going to be filling in the heating design load and the output of your heating system. And you remember the heating system output has to be no more than, depending on the type of system, either 15% or 40% higher than the design load. So it's going to be very obvious right here whether you've met that requirement or not. So for all of this, I'm just reminding builders that you should talk to your heating system person early in the process and make sure that they know that you are expecting them to do a heat load calc and to provide you with the results of that calculation, and you are expecting them to select equipment that meets the energy code requirements. And there's a checkbox for programmable thermostat, or I didn't do a programmable thermostat, and here's the reason why. And then there's ducts, and this has to do with whether or not you ran any ducts outside the thermal envelope, and if so, did you do all the stuff you're supposed to do whenever you do that? And then there's a couple of small things at the bottom where they just cover things like the mechanical system piping and the lighting efficiency and the solar pool heater and that sort of thing. And then on the bottom is where the builder signs, I certify to the new owner that the above information is correct and that the premises listed above have been constructed in accordance with the Vermont residential building standards. And the builder signs that, dates it, and as I said, files that in the town land records, sends one copy to Montpelier, posts one copy at the house, and presumably keeps one copy for their records. If you're an owner builder rather than a standard situation, there is a disclosure statement. It's almost entirely exactly the same as the certificate. Again, to remind, not everybody can do this. You have to meet the requirements of the owner builder definition. That's what the owner builder disclosure statement is. You can see it has almost all exactly the same information. So you still have to do all of this, even if you're an owner builder. It says at the top, owner builder disclosure statement. And instead of saying this house meets the requirements, it says, this home does not meet the technical requirements of the Vermont Residential Building Energy Standards and is not required to do so. So it's still legal, but it doesn't meet the technical requirements. And all the rest is pretty much the same. And at the bottom, it's pretty much the same, except it says, I certify that the above information is correct and that the premises listed have not been constructed in accordance with the Vermont Residential Building Energy Standards. So that's the difference between the two certificates. So to summarize, what does a builder have to do? There's 10 or 12 basic requirements you have to make sure you incorporate into the project. There's ventilation and combustion safety requirements. There is an overall performance requirement, and there are 3 choices as to how to demonstrate that you have met that requirement. You can either do the packages plus points method, you can do the software method, or you can have Efficiency Vermont do the home energy method. And then you need to do the certification. So that's what the builder, that's at least in my head, that's how I organize what the builder has to do. Basic requirements, ventilation and combustion safety, overall performance requirement, 3 options, and certification. If you get stuck, I mentioned this website before. This is where all of the materials live, and if you want to get in touch with the Public Service Department, that's where to go. There is also an Energy Code Assistance Center, which is a toll-free line. And if you get stuck at any point, or you're reading through the handbook or that sort of thing, and you need some help, you can call that line. And with that, we are pretty much done. So I'm going to turn it back to Bryn and see where we go from here.
Great. Thanks so much, Dave. That was really thorough and definitely packed full of information. I am just going to add a link in the chat for how to find additional energy code scheduled webinars throughout the summer to see when those are coming up next. And at this point, we have 20 minutes scheduled to take questions, but we also have flexibility to go longer if there's interest and need. So I am not able to unmute folks on the call, so you would have to do that yourself if you want to just ask a question to Dave directly, or certainly add anything into the chat and I can relay that to Dave as well. I think we could start off, Dave, just with some discussion elements on what are some of the most common questions that you do get about RVs?
Well, we get a lot of code certificate questions after the fact, when those tend to happen when the house is on the market and people are panicking because they've just discovered that there is no energy code certificate. We get a lot of questions on that. We get some questions on the combustion safety requirements because folks are not used to them. The same thing happened with mechanical ventilation when we first started requiring it. We tended to get a lot of questions, but a lot of the builders are more used to that now. We get questions and perhaps even more comments from builders about the organization of the code, specifically as it relates to enforcement. And although it's easy to assume that builders in general would want less enforcement, we get an awful lot of comments in exactly the opposite direction. And the most important one, the most common one goes something like, I really wish we had inspectors for this because I'm trying to pay attention and I'm trying to comply with the law and I'm building buildings, in accordance with the code, at least to the extent that I understand it and can. But I'm having to bid against people who are just ignoring the code. Some of them don't even know that it exists. Some of them know that it exists, but they know that the chances of being called to task for ignoring it are very small, so they just ignore it. Or maybe there's pieces of it that they don't understand and they just figure, well, nobody's ever going to check up on this anyway. So, the most frequent criticism I hear of the code from builders is not that it's requiring them to do too much, although we do hear that requirement with that comment, definitely. But the most common one is we should have some enforcement, because I want everybody to have, on a level, I want a level playing field. Like, I feel like I can compete against these folks on a level playing field, but they're, the homeowner's taking their proposal because it's $2,000 cheaper, and they don't even realize that, there's a lot of things that other contractor is supposed to be doing that they're not going to do. And that's why they're able to bid lower.
Gotcha. So we do have a technical question that came in. How are area calculations done for point systems? Is it conditioned space?
Yep, it's conditioned floor area, even if it is unfinished. So it's whatever area the code would consider to be at least partially conditioned. And in general, that includes anything that is inside the insulation layer or has a heating equipment in it or has heating distribution in it. So that would mean definitely anywhere where there is deliberate heating distribution, but it also would include anywhere that is within the thermal envelope. So that probably, in new construction in Vermont, that almost always includes the basement. So even if the basement is unfinished, you would use the area of the basement floor. And then you may also have some sort of utility or storage space that may be unfinished and may not have any deliberate heat inside of it, but we're at least partially conditioning it because it's inside the insulation layer and it runs closer to inside temperature than to outside temperature. So the code would consider that part of the conditioned space. So it's floor area, the total floor area of all of the conditioned space or partially conditioned space, which as a practical matter means everything inside the insulation layer.
All right, thank you. I am curious if there's any additional guidance you can provide about existing homes and some of the nuances there. I know there's often, different situations and scenarios that come up of wondering what may push something to require code to be met.
Most of the things that would require code to be met were right in that section that I went through. So it's basically the most common things are attic insulation and basement wall insulation. And if you're if you're saying, what are the things that people commonly do to houses where what they're required to do by code might be more stringent than what they might do otherwise, the two areas are basically attics and basements, because those are pretty much the areas where homeowners would be tempted to add insulation. Mm-hmm. In the case of attics, it may not make much practical difference because a good insulation contractor is going to insulate your attic to like R60 anyway. So that probably doesn't matter in terms of insulation requirements. The same is probably true for windows. So if you're replacing windows, you do have to buy windows that have a U value of below 0.3, but you probably just do that by accident because all the window suppliers in Vermont know that you need something below 0.3. So you'd probably have to special order to get something worse than that. So you probably get something good enough just by accident on windows. Mm-hmm. The one place where it does matter is basements, where the code requires at least R15, assuming that you're doing continuous insulation. That's depending on the type of foam you use, that's probably somewhere between 2¼ and 3 inches of foam. And there are a fair number of basement walls that get insulated with less thickness than that. So, for instance, a homeowner doing their own, they might end up doing 2 inches of extruded polystyrene where the code requires 3. So that is one instance where the code would push you to do something that you might not necessarily otherwise do. But it's not pushing you to do something that's difficult to do. It's, you know, it's easy. It's just as easy to put 3 inches on as it is 2 inches, pretty much. So insulating your basement walls in your existing home is not a whole lot different than insulating basement walls in a brand new home. So the requirements are pretty much the same. And in the case of areas where conflicts might exist, like the gut rehab, where a contractor might be looking at the new code and saying, well, I'm supposed to do an R25 wall, but this wall only has a 3.5 inch cavity. How am I going to get R25 in a 3.5 inch cavity? Well, the code handles that specifically by exempting that and saying you don't have to do that. You only have to fill the cavity. And similarly with roofs, if you are insulating the roof, you're not required to make the roof assembly thicker so that you can get to the current code value. You're only required to fill what's there.
Okay. And can you speak to any updates or changes regarding blower door testing between this code and the previous code?
Well, the biggest one is that it's now required. The previous code had offered 2 options for air sealing. It said that air sealing was supposed to happen, provided some level of detail about the locations that we're talking about. And it said that the builder was required to either do a checklist or a blower door test. So they could do a blower door test, and if they were below 3 ACH 50, they're deemed to comply with the air tightness. The other way that they could comply is to do a checklist, and the checklist was right in the handbook, and it required the builder to, you know, literally walk around the building, visually inspect those locations, and check them off that they had been sealed. And under the code we're in as of today, that's an acceptable alternative. So you either do the blower door test or you do the checklist. On September 1st, when the new code kicks in, the checklist will go away. That's no longer an option. Now you'll have to do the test.
All right, thank you. Are there any other questions for Dave?
Hey, it's Phoebe. Quick question. Dave, can you go back to that very first slide that was just the overview of the substantive changes for 2020?
Probably.
Cool, thank you.
Let's see if I can find it. Okay.
Thank you.
Did I get it on your screen?
Yeah. Just for my curiosity. Yep. Thank you. And thank you for the presentation.
You're welcome.
Great. And as a quick update, so on regarding the handbook specifically, that is being wrapped up. Some final tweaks are being added into the handbook and is being formatted for print. So hopefully we will have final version, a digital version of that within the next 2 weeks, and can take requests for hard copies that we can mail out, since we're not able to do in-person workshops, that we can mail out later on once we get hard copies printed later in July, early August. So you can certainly send any requests to me. I'll put my email address in the chat so that you can send that right to me.
Oh, and if I could just throw in one other thing, the handbook will be posted on the Public Service Department's website. It's not there yet, but they're just finalizing it right now. So I would think that it may be available on the website before it's actually been printed and available on paper. So if you want to get that as soon as possible, you might want to keep an eye on that web page, because I would guess they might be posting the electronic copy within the next week or so.
So Dave, our marketing team is working with the department on that, and I'm anticipating maybe a couple more weeks. I don't think
Okay.
it'll be quite ready next week due to the long holiday weekend and a couple just final tweaks. So soon, but maybe not next week.
Okay.
Yeah. All right. Well, I think we're going to wrap things up. Certainly reach out to me for additional trainings or requests for handbooks. I'm happy to also send you a direct email when that digital copy of the handbook is ready, so you don't have to look for it yourself. Just let me know. And yeah, check out our website for additional trainings. So happy to have you join us this afternoon, and I hope you have a great rest of your week. Thanks so much. Thank you,
Thanks
Dave.
for your help, Bryn.
You bet. Bye-bye.